In this video, we're going to talk about the way that we can evaluate a recursive function, especially ones that start to get a little bit more complicated. And this model is pretty similar to the way that most programming languages evaluate recursive functions. So what we have here is a function called evaluate, and it has two inputs. They are a and b. This function is supposed to return an integer value. And we can tell it's a recursive function because there's a command in here that is referring to the function again, so this is self-referential. And there also appears to be what we think is a base case, because if the b parameter ever gets less than or equal to 0, the function does not refer to itself, it just generates a value. And specifically, we want to know what happens if we call this recursive function with the inputs of 5 and 2. So when we call this function with inputs of 5 and 2, that means for A, we get an input value of 5, and for B, we get an input value of 2. What happens then is it starts running through the code, so it's not true that B is less than or equal to 0, so it runs the else case. And the first interesting thing that happens is it sets x to be the result of calling this function again, but the inputs to the function have been modified. So it says the first input will be 1 bigger than the current A, and the second input will be 1 less than the current B. So these aren't changing A and B, they're calling the function again with modified values. So that means this first input should be 6, and the second input's going to be 1. So what happens is we actually end up with another almost version of the function that appears in memory that looks like this. But here, the input is 6 for A, and the input for B is the number 1. And we do the exact same process again. It says, all right, is it true that our B is less than or equal to 0? It is not, so we run the else. And once again, we're going to assign x to be the result of calling the evaluate function with 1 bigger than A and 1 less than B. So that means we're calling it with 7 and 0. So we get another sort of version of the function being called here. But this time, we have that our A value is 7. That's a terrible 7. 7. And our B value is 0. And for some reason, it's trying to fix my writing, which is making me kind of unhappy, but that's a 0. All right, so now we run through the code again. Is 0 less than or equal to 0? It is, so we're going to return our value of 0. So our number 0 is going to be sent back to our function that originally called it. So if you remember, and now I'm going to destroy this stuff that we have here, we were calling this function from another place in memory. So I'm going to delete all of this. I'll do it all at once. Boom. And when we come back here, all of this code that we had, the evaluate function, all just becomes the number 0. And it goes into the variable x. So our x is the value 0. Then y is the sum of a and b, which in this function is 7. And then our result is whatever x plus y is, and 0 plus 7 is the value 7. So because this function evaluates to 7, now we're going to take that number that's returned, and we're going to plug it back in here, because, let's see if I can select all this at once. Yep. We had called the evaluate function with that data passed into it, and it evaluated to the number 7. We're now going to use that as our x. Our y is a plus b, which in this function call was 2 plus 5. So that's 7. Once again, it's fighting me. There's my 7. And our goal is to return x plus y. Here, x plus y is the value 14. So by the end of our chain of recursion, the function evaluate 5, 2. Not sure where my arrow's going. There we go. That gives us the value of 14. So hopefully that gives you a model for understanding how function calls kind of work. Every time you call the function again, it's almost like another function gets created, and you have different input parameters. And when you get to the bottom, when you get to the base case, you work backwards to plug into the values.